Hello, AB Video 7.2D Part 1, Introduction to Volumes by Cross Sections. Okay, so I am going to pause this right now and show you because you are going to want to see this. Okay, so this is the calculus in motion. So what we have is we are in an airplane, and right now what you're looking at is the foundation of your home. So you're looking at it from above. So you're going to build this home with a round foundation, okay? You're going to have a round house. What we're going to do now is we're going to drop that. So now we're going to take our helicopter and we're going to come down to ground level. So looking at it from across the street, it now looks like an oval, but it's because of the perspective, okay? So here's what we have. We're going to find the volume of a solid where the cross sections perpendicular to a fixed diameter, which in this case is the x-axis. It's either the x or the y-axis. The base is a circle, and the cross sections are going to be squares, okay? So here's an example of 4 of the squares. So the biggest square, of course, is going to be at the biggest spot on the circle, which is at its diameter. So you're going to go from one end of the foundation to the other. That's, let's say, whatever, it's 4 feet total diameter, okay? Then you're going to go up 4, right 4, down 4. The next one, of course, from one point on the circle to another is going to be a bit smaller, and they're just going to keep getting smaller. And you should try and picture what's going to happen if I fill this with these squares, okay? All right, so I'm going to sweep one so you can see where it starts. So this is what it does. As we go across, the squares get bigger and bigger and bigger. And then they get smaller and smaller and smaller. And here, in case you were wondering what that solid looks like, not that you're ever going to have to know this, but here's what the solid would actually look like. So this is your very cool house. Okay, so I'm going to show you the solid. That's what the actual solid looks like. Here's those 4 squares inside the solid, and here's the solid with the squares running through it. So the object of our game is to find the volume of this guy. Now, of course, we know the area of a square formula, and I'm going to show you how that works right now. All right, so, ooh, that was weird. Didn't mean for that to go anywhere. All right, so these are my steps. You're not going to find this in the book. The first thing you're going to do is draw an aerial view of the graph of the base. So let's say they tell you the base is x squared plus y squared equals 4, which is this circle. So that's what it looks like from above. Then draw a side view of the base. So you're going to take your x-axis and put it here. It's kind of like a big X for your x and y axis. And then your circle becomes more like an oval, right, from looking at it from the side. Draw one cross section and label its endpoint. So I'm going to pretend that this is going to be perpendicular to the x-axis, okay? So if I look at this circle up here, what I have is this segment I've just drawn right here is this segment right here, and it's perpendicular to the x-axis. Well, there's a theorem in geometry that you learn that says when a chord is perpendicular to a diameter, the chord gets bisected. So if you call that the point x0 and you call this the point xy, so this is x0, this is let xy, well, what happens, because these are the same length, that makes this the point x negative y, which makes the length of the side of the square 2y. So you're going to find the area of the cross section, which is 2y squared, 2y times 2y. Then you're going to find the volume of a slice. I'll show you how to do that in a second. And then you're going to set up an integral that'll find the volume of the entire solid. Okay, so let's see one. Okay, so let's take a circle base x squared plus y squared equals 9. The cross sections are perpendicular to the x-axis and are squares. So this is with actual numbers, and we're going to work this one all the way through. So there's our circular base. There's 3, 0, 0, 3, negative 3, 0, 0, negative 3. Perpendicular to our x-axis. Now when you're drawing this, I know it's weird to draw perpendicular at an angle, but think of perpendicular to the x-axis as parallel to the y-axis. Like here, that is parallel to the y-axis. So just draw a segment from one edge of the circular base to the other that is parallel to the y-axis. Okay, so as we said, this chord gets bisected. So if that's the point xy, that's the point x negative y, which makes the length of the side of the square, 2y. So the area of the square is 4y squared. To be honest with you, that's the hardest part, is getting to there. After that, it's really easy. What I do is I take that square base and I give it a little thickness, like a slice of bread. So instead of a coaster, which has no thickness, I've turned it into a slice of bread. What happens is this thickness right here being along the x-axis is dx. So this is really simple. If it's perpendicular to the x-axis, that height basically is going to be dx. Okay, if this was y-axis, this would be dy. Now this is actually a prism. Here's the base of the prism. The formula for the volume of a prism is the area of the base, which we already know is 4y squared. You're just going to take the answer you got here and put it here, times the height, which is dx. So really the shortcut is, once you have the area of the cross section, if this is perpendicular to the x-axis, you're just going to multiply that area by dx. After that, we're just going to take that expression, 4y squared dx, and we're going to find the volume of the solid by adding up the volumes of each one of those little slices of bread. Now, this is what decides what's going on. So since that's dx, that has to be from x equals to x equals. So the left border is x equals -3. The right border is x equals 3. But the problem is this is in terms of y, and it's dx. So you go back to your equation and go, oh, okay, if x squared plus y squared is 9, then y squared is 9 minus x squared, and therefore you can replace y squared by 9 minus x squared. The other thing that they can do, and they will do this in multiple choice, this is a symmetric base, so you could do -3 to 3, you could do 2 times 0 to 3, or you could do 2 times -3 to 0. So any one of those would be fine. Okay, so these are just more and more examples. I'm going to give you a lot of them. I know these videos are long, but I just want to give you a lot of examples. You feel free to look at every second one if you want. Find the volume of the solid. I don't know why that says solids. Solid, whose base, didn't mean to do that, is bounded by the circle. Again, nice easy circle base, x squared plus y squared equals 4, where the integrated cross sections taken perpendicular to the x-axis. Okay, so this particular time, oh no, should be over here, I would think. Okay, so this time the cross sections are square, so this is extremely similar to the last problem. It's really the same idea, only instead of the radius being 2, it's 3. Okay, so same idea, that's going to be 2y. If that's a square, the area is 4y squared. It's perpendicular to the x-axis. You'll stick a dx on it. And then because it's x, it'll go from the left border to the right border of this expression. And of course, you can't leave the y squared because it has to be in terms of x. But x squared plus y squared was 4 on the base, so y squared is 4 minus x squared. So